Assalamualaikum and a very good day everyone. I am Muslim Hakim, BAA2323, and today I am very excited to present our project on the hydraulic modeling using Hydrologic Engineering Center's River Analysis System, which known as the Hec-Ras. So Hec-Ras is actually a widely used tool for simulating river hydraulics, predicting water surface profiles, and also analyzing flood risk. It is an essential software for engineers working in water resources management and also floodplain analysis. So hydraulic modeling basically plays a vital role in managing rivers and water systems. It helps us to understand river behavior, design sustainable infrastructure, and also prepare for extreme events like floods. In this project, we are going to explore how Hec-Ras can be used to model a river system and provide insights into its hydraulic characteristics. So our project basically aims to construct a Hec-Ras model for a river system using provided data, and we are going to simulate two types of flow conditions. First one is the steady flow, and also second one is the unsteady flow, and we are going to compare the result to better understand their impact on flow depth, velocity, and also the discharge.
The river system analysed in this project represent a typical water course prone to dynamic flow conditions. The data for the river, including cross-section coordinates and flow rates, was provided as part of the project dataset. We used the dataset that have been given by our lecturer, which includes river cross-sections, flow conditions, and boundary data. Additionally, key parameters like downstream reach lengths and Manning's value were customized based on the group members' student IDs. For example, the average of the last 3 digits of our IDs determine the specific values for these parameters, making the model unique to our group. As I have mentioned before, in our analysis, we focus on two types of hydraulic flow conditions, which is steady flow and also unsteady flow. Steady flow occurs when flow characteristics such as velocity, depth, and discharge remain constant over time at a given location. This type of analysis is useful for scenarios where conditions are relatively stable, like designing canals or analyzing long-term river behavior. On the other hand, unsteady flow refers to situations where these characteristics change over time, such as during floods, dam breaks, or storm surge. This type of analysis captures the dynamic nature of real-world river systems and helps predict how they respond to time-varying inputs. By simulating both steady and unsteady flow, we aim to understand the differences between constant and dynamic hydraulic conditions and their impact on flow depth, velocity, and discharge. This analysis is significant because it highlights the importance of hydraulic modeling in predicting and managing river behaviors. It also demonstrates the practical use of Hec-Ras in solving real-world water resource challenges, such as flood risk assessment and infrastructure design. With the introduction and background covered, we will now move to the explaining the methodology, where we detail the step-by-step process of building our Hec-Ras model and conducting these simulations. Thank you.
Assalamualaikum and hi, my name is Nia Stasha Binti Shazli, ID number AA23108. I will explain to you about the step-by-step to use the Hec-Ras software. Firstly, you need to open the Hec-Ras software, then save file in your desktop. We need to change the unit to SI unit. In order to change the unit, we need to click option, then click the unit system US customary /SI button. Then click the system international in bracket metric system. Okay, then click the circle button, and then after the button is clicked, the screen will appear like this. After the white screen has appeared, click the river reach button and draw a line anywhere you like on the screen. After the line is drawn, the screen will show a message. A new reach will be created below split. Enter the new name. So, name the river as Sleepy's River and the reach as Sleepy's upstream. Then, the line that we just created will has the arrow that shows the direction of flow for the river. Next, we repeat the same step for Tempera River. Draw a line that touch the Lipis River and give a name to the river as Tempera River. You will require to name a junction. We need to refer to the spreadsheet for the name of the junction. So from the spreadsheet, the name of our group, the name for the junction is LT. The picture on the right is the line of the river after the junction is added. After that, click the GIS tool button and click the Reach Invert Line Table button. The screen will then appear the table. To insert the data, in order to fill in the table, we need to take the data from the spreadsheet for the Lipis River, Lipis upstream. Then we copy paste the data from the spreadsheet and copy the data from the spreadsheet and paste it to the table in the Hec-Ras software. We need to then repeat the same process for Lipis downstream and Tempera River. So this is the real reach of the river after the table has been filled in with the data from the spreadsheet. Next step is click on the cross section button. And after we click it, the screen will appear like in the slide. We need to insert the data from the spreadsheet based on the river station to the cross-section coordinate. After all the data is entered, click the Apply Data button. After that, the graph will be shown. We need to repeat the process for the other river station. In order to do that, we need to click the option and click Add a new cross-section. So we just need to insert the data from the spreadsheet. So these are the cross sections after all the data is entered. Then we need to insert the junction length. To do that, click the button junction and it will appear the table of the length of the junction data. Insert the junction length with any value if not given in the spreadsheet. For example, our group entered one for Lipis River and one for Tempera River. Then click OK. That's all for the cross-section part.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Arina Sofia Binti Latif. My nometric is AA2323. So, at my part, I wanted to talk for Hec-Ras. We need to copy the file into two. That is steady flow and unsteady flow. And first, we want to open the file for steady flow. Okay, for the steady flow data, first we need to click the icon that we circle in the button. Then the table will pop up. So we need to insert the Lipis upstream, Lipis downstream, and Tempera to get the data. So insert the data flow according to the data from the Excel spreadsheet that we have done. The next step is you need to click the reach boundary condition. After you have clicked, it will show the steady flow boundary condition. So at the steady flow boundary condition, it will show the upstream and downstream. So click at the blank space at upstream and click at normal depth. After you have clicked the normal depth, it will show enter the upstream slope for normal depth computation for which Lipis upstream for all profile. So for example, I enter 0.001. and then press OK. After you fill in the upstream, you need to fill downstream and for Tempere. So it will show the full data of the river. So the data will be added and we click OK and click the apply data. Then we need to save the flow data. So to save the flow data, we need to click file and save the flow data. If you want to save the flow data, you need to make sure the name of the flow data file do not have any spacing. For example, see at the steady flow that we have saved. For example, steady underscore flow. So this show the flow data has been saved. After that, you need to click the button that we had circled and then click to compute. After you had clicked, the screen will appear like this and it will show the steady flow simulation Hec-Ras and the computation summary will be shown. So you need to click the button that we had circled to display the profile. After you click, it will show the profile and you can click the arrow button to show other reaches profile. Next, you can click at the cross section to display the cross section button to display the cross section. Click the arrow button to show other reaches cross section. For example, at Lipis River, at Lipis upstream and Lipis downstream, and Tempere. Change the river to see other rivers cross section. After finish the steady flow profile, let's go open the unsteady flow profile next. So the next step is you need to click the button that we have circled, and when you click the button, click the blank space in the boundary condition and click the flow hydrograph button. When you click the flow hydrograph button, go to the spreadsheet and copy all the data at the unsteady flow data flow rate. And then you need to key in the data at the flow. So you need to key in all the data that we have copy paste from the spreadsheet and then repeat the process for the Tempere River next. So next, at boundary condition types, you need to click at normal depth. After you click the normal depth, it will show the normal depth downstream boundary. So you need to fill in the friction slope. So you need to see in the data spreadsheet that we have filled in. So take the normal depth, for example 0.002 and click OK. So next, at boundary condition, you need to click at initial condition. At initial condition, you need to fill in any value and click apply data. So you need to click the button that we have circled and it will show the unsteady flow analysis, and then you need to click compute. After that, the screen will appear like this and it will show the geometry processor, unsteady flow simulation, post-process, all the data of the unsteady flow. So you need to click the button that we have circled and it will display the profile. And if you want to see other profile, you need to click the arrow button and it will show other reaches profile. Lastly, you need to click the button of cross section to display other cross section. So if you want to see other reaches cross section, you need to click at the arrow button. So lastly, you need to change the river to see other river cross section. For example, Lipis River, Lipis upstream and Lipis downstream, and Tempere River. That's all.